Okay, so this segment of the investigation will be about mineral hardness. So you should be on that slide within the mineral slideshow that says B hardness. And it says that that's the resistance a mineral has to being scratched. So basically, here's the deal. If you look at the chart on that slide, a scientist with the last name Mo came up with a hardness scale for basically all earthbound substances, and that includes minerals and metals and some other things. But if you take a look at that, the hardest substance that we know of is actually something you probably all would love to have more of, and so would I, which is diamond, and that is a hardness of 10 on that scale. So all other minerals that we are going to deal with in this are going to have a hardness of less than 10. So, and if you look on down that chart, you'll see some familiar ones that you might know of as birthstones and so on, and then some you may not know. So what I've got in front of you now is a few minerals to look at, but also some tools. And we actually have 3 tools here. We've got an iron nail, a just normal copper plated penny, and a piece of glass. And one that is not there that we all have built in is our actual fingernail. So if you click forward through the slideshow, you'll notice that, yeah, there's minerals that have a certain hardness, but we also know the hardness of things like iron, which is this nail, and that has a hardness of 5.5. This penny right here, anything that's copper, has a hardness of about 3.0. And this glass plate that I have here, most glass, it has some variance, but most glass is around 6, and that's what ours is here. So here's what you're going to do. By figuring out the hardness of an unknown mineral, you can actually narrow down what that mineral is, which I'll show you when we use our charts a little bit later, how to do that. But for now, we're going to go, if you go to the next slide, there's something called the scratch test, which talks about or is a process by which you can figure out the hardness of a mineral. And again, it's not going to be perfect. It's going to be a ballpark thing. So I'll kind of go through that with you. So first, the hardness test is basically you take any 2 things that you know the hardness of, or one you don't know the hardness of, it could be either, and you scratch them against each other and you see who wins. It's like a little battle royale of scratching. So I'm going to do the first one here with, this is a mineral called gypsum, and you may know or have heard of gypsum, but for now we're just going to kind of look at this one, and I'm going to use my fingernail, which I know is a 2.5, and I'm going to decide, okay, is my fingernail harder or softer than gypsum? And the way you do that is you just do a little scratch. You can hear that ugly sound, and you can see right there, there's a scratch on there that does not wipe away, and that is saying that gypsum, this mineral, is softer than my fingernail, which means it's softer than 2.5. How soft is it? Well, we could go a little more detailed and maybe use this against talc, which is a really soft mineral you saw on the chart on the previous slide. But we really are just trying to get a ballpark. This is, I can say less than 2.5, so maybe a 2.0 or a 1.5 or something like that, and that's about good enough. And does that, you know, if you look at some of the other options you have, here's a nail. What do you think is going to happen if I scratch the gypsum with the nail? Well, this has a hardness of 5.5. We just said that the mineral has a hardness less than 2.5, so sure enough, that's going to leave a scratch. So you all see that, right? And that they don't wipe away. That's the important part. So that scratch is permanent, unless I kind of sand it out a little bit. That's a real scratch. So here's a fun thing. This is a different mineral. If I do the exact same thing, I'm going to scratch this with my fingernail, and no matter how hard I try, there is nothing happening here. And this, you can look up, this is quartz, and quartz is a really hard mineral. So we're not going to have a lot of luck scratching this with anything. And this right here is a nail, and you would think, oh, sure, this nail is going to mess this nice, pretty, clear surface right up. See how shiny that is? I can go at it all day long, and it's hard to see, a little bit blurry, but no scratch. And you can actually get a flashlight out and shine it at this thing and shine it through it, and you can see that's still as shiny and gorgeous as it was before. What you may notice, there's a good angle on that. That is not scratched. What you may notice though sometimes is if I do this enough, you're going to get like what looks like a scratch, but it's actually just a bunch of dust or shavings from this iron nail getting left behind because it's actually wearing away the nail, which is kind of hard to believe. So quartz is tough stuff. So what we could do, now here's the deal, glass is 6, and right now glass is the hardest tool I have here. This nail is 5.5, this glass is supposed to be 6. So what I won't do is take the glass and start scratching the quartz. Here's what you will do. On a nice flat surface, and you can sort of see, I'm going to go probably up here in the top right corner for you. I'm going to just use the mineral and try to scratch the glass, and it does make a pretty horrible sound, but ooh, there we go. So you can all see that just happened. I just did that. That is a scratch, and if I wipe that, a little bit of the dust goes away. That's pieces of glass, actually, but there's still a scratch left behind. And if you listen, that clicking sound is the scratch of my nail moving through that groove that I just made in the glass. So what I'm saying there is that this quartz is harder than that glass. And that is a 6.0. So quartz is harder than 6.0. That's pretty impressive. If you look at the scale, it only goes to 10. So we're at least a 6.5, 7, 7.5, something like that. And that's pretty cool. Another quick thing, just to show that this happens, on a penny, we just said quartz is way harder than a 6, probably. The penny is only a 3. Well, what do you think is going to happen when I scratch the penny with the quartz? Well, probably what you would predict. I'm going to go right across the face of the penny, and if you look, it's a little hard to see. I might try to shine the light in there. There we go. There's a, got to kind of go indirect because this light is kind of weird. So you see that groove right there? That is a scratch. Nice shiny, there it is right there. That is a nice shiny scratch that I just made with the quartz on that penny, and that shines because it scratches the tarnish off the penny and it makes that fresh new copper show up. So you can sort of see that right there. All right, so that's the scratch test where you can say, okay, whatever I just scratched this penny with, this penny is softer than that thing. So that's how that works. I wanted to kind of go through a couple other ones with you. This is galena, the mineral. Really nice, shiny, metallic luster. We talked about that. It also has some other interesting things. It's actually super heavy for its size, so it's got high density. Funny thing is, though, even though you look at this with the sharp corners and all, and you think, oh, wow, that's going to scratch the heck out of the glass, I'm going to kind of go right around in this area where you don't see too many other scratches, and I'm just going to grind away here, and you're going to see nothing, just dust from that mineral actually breaking apart. So I can say that this mineral now is softer than 6. And we can go ahead and do more tests on it and figure out, you know, is it softer than my fingernail? It's actually not quite there. It's almost about the same as my fingernail. You'll see a little bit of dust coming off there. It's actually on my finger and in my fingernail. That's a indicator that this might be around a 2.5 or so. But certainly, if I were to scratch this with the nail, let's see if I can find a good spot here. You can hear that. What's right in there is a new scratch that I can make. So this is softer than 5.5 as well. It's actually really soft galena. If you look it up, it's about 2 or 2.5. Okay, so that's that. I did want to show you some pyrite because I did show you this pyrite in the last video. That's my nice one. Pyrite can sometimes look a little less extravagant and a little more dull. It still has sparkles, which you can sort of see there. But I wanted to show you that pyrite is also a pretty hard mineral because I can scratch the glass and you can see that big scratch that I just made right there. Doesn't wipe away. So pyrite is also harder than glass, so you can sort of see. Now, we could do more intricate testing where you can try scratching one mineral with another mineral and see how that works. Basically, the way the hardness test is, you can scratch with a tool, you can scratch the mineral, or you can take the mineral and scratch the tool and see which one leaves a scratch, and whoever does is the harder of the two substances. So that's how the scratch test works. The last note of caution on that slide is don't confuse hardness with how the mineral breaks or how easily it breaks, because I mean I can't scratch this quartz but I can certainly, with a hammer, I can probably break it. And when you break it, you get this awful, jagged looking, dull colored, it really messes up the mineral sample. That's what happens when you break it. Breaking and scratching are two different things. And I want you to think about, looking back at the slide with all the hardnesses, things like diamond, topaz, looks like, and there's some other ones in there that are birthstones. I believe garnet might be one of those that has a really high hardness. Why might we use minerals with high hardness as jewelry? Well, the answer is, and you could think of this as a diamond almost, not quite as hard, but if you were wearing this as jewelry and you were to accidentally kind of scrape it against some bricks or something like that by accident, or you were to drop it on a sidewalk, would it scratch? And the answer is no. And that's why we use minerals with high hardness as jewelry or birthstones or things like that, because they are really resilient and they don't scratch easily. But it doesn't mean you can't break it. It just means that it won't, if I were to scrape something against it, the surface will stay nice and shiny like you see here. So that is the little spiel on mineral hardness.